Good afternoon, all. Myself, Nagananda from SIMULIA team, EDS Technologies. Welcome you all for today's webinar on integrated modeling and simulation for faster innovation. I thank all the participants for taking out time from their busy schedule to be part of this interactive webinar session. So in this session, the ModSim, which is modeling and simulation, actually requires an average flow of the design process, which begins with the CAD modeling and performed by the design engineers. The objective will be to develop the model which satisfies all the design criteria before sharing the design to the simulation engineers for the validation purpose. So this process usually goes to and fro until all the design concepts are accepted. So in order to discuss on these parameters, so today in this webinar, let us understand how the ModSim can facilitate the CAD and the CAE to work seamlessly, enabling the product development, and also how ModSim benefits the organization. So to talk on this, we have Miss Geeta, and I'll give you a brief about her. So Miss Geeta Aula is an industrial process consultant and senior manager at Dassault Systems, and she's having a career with Dassault Systems and started her career in 2004 as an application engineer, and she is now in the senior technical manager capacity, and she has supported many customers in various industrial segments on technical supports, trainings, best practices and methodologies, set up in the usage of the software, especially on Abacus. And in her current role, she is responsible for driving initiatives such as electrical vehicles, ModSim, cloud-based solutions, and guide companies on the technology that Dassault Systems has to offer. She holds a master's degree in computational mechanics of materials and structures from Stuttgart University, Germany. And we also have followed by this particular presentation by Ms. Geeta, we have Mr. Dayanidhi Panda, industrial process consultant and senior specialist Dassault Systems, who will demonstrate the process. And Mr. Dayanidhi Panda has been a part of SIMULIA for the past 13 years and part of industry team. And his areas of technical expertise includes SIMULIA on 3D experience, platform, composites, optimization, and multi-body simulations. He has worked with various organizations under T&M and A&D, such as Bombardier, Tenneco, L&T, Ashok Leyland, and so on. And also, he holds a bachelor's degree from mechanical engineering and a master's in thermal engineering. So I would like to ask Ms. Geeta ma'am to take over.
Thanks, Nagananda, for the nice introduction to this session. And welcome all, and a very good afternoon to everyone. In the session today, we'll talk about how modeling and simulation can work hand in hand to build better products and to be able to get better insights into the products that we are building today. So myself, Geeta, and my colleague Dayanidhi, both of us will be taking the session today. So to get started, so before we move on, maybe we'll just spend a couple of minutes to take a quick look of how CAD and CAE have evolved in the last couple of decades. So if we see way back in 1990s or early 2000, people used to work just with the geometry or just the design. And of late, we have moved into knowledge-based engineering, and now we are looking at experiential engineering, where we're trying to give the required experience in driving the designs itself, and using methods like generative design to come up with optimal technologies, and using automation and templatization in our regular CAD and CAE process to come up with better products. And in future there are also people are also are looking at cognitive engineering, wherein they're trying to use AI ML based type of engineering methods to come up with the best design possible. So we see that the whole of CAD and CAE domains have evolved quite a bit over the last couple of decades, and new technology and new methods are being developed to help the users come up with the best design in the shortest time frame possible. So if you look at the usual design process, I'm sure most of you are already familiar with this design process. So typically we start off with the concept design phase, and then move on to the detailed designing phase, and do the verification and validation studies, and then look at manufacturing. So if you look at each of these design phases, there are so many iterations that are done to come up. Let's say in the concept design itself, people do a lot of brainstorming to come up with a lot of ideas, and then come up with a concept design. And after that, they try to add in more details and keep refining the design to come up with the final design. And once the final design is in place, then virtual simulations are used to perform the required testing to ensure the structural integrity of the product, or subjected to various kinds of testing. And then finally it goes into manufacturing. Now each of this design process in itself has quite a few challenges, and I'm sure everybody would agree with me that let's say if we take, for example, the concept design stage. So how can I choose the best concept design? One could probably come up with a lot of designs from the concept design itself, but among them, how do I choose the one best design? Now typically this could be done maybe, let's say, based on the engineer's experience, or maybe hand calculations, or maybe based on the suggestions, feedback, experience given by experience the person had from designing such products in the past. But obviously it's going to have some consequences on the final product. That is, maybe the product is over designed, there is no optimization considered, probably there is no time for the designer to explore a lot of design alternatives, and most importantly, there is no capture of knowledge, know-how, the best practices. Even if it is the optimal design, probably there is no track of how that design was created, how the best practices were captured. So that's in the concept design phase. So if we move, let's say, to the detailed design and testing phase, so here again the user hits a lot of challenges. That is, once the detailed design is in place, how does the person submit it to the experts? They need to submit it to the analysts, experts for validation, which means the designers have to rely on analysts to perform all different kinds of simulations. Now here again, it could be that there are only limited products, or few people who know how to do a certain level of simulations, and given the time constraint, maybe they are able to try out only few iterations, and basically do few simulations. And again, prototyping. Now obviously prototyping is a very expensive scenario. So one would look at prototyping only for the last best design, so that they can use it for certification. So if we look at the consequences again, all of this add up to a lot of time consuming operations, and one would end up doing a lot of back and forth iterations for fine tuning the design, getting the right simulations. And if at all the design is not the best, then maybe a lot of prototype models also needs to build again and again. And if this is all manual, then obviously there are chances of errors kicking in. So if you see at any phase of the design, be it either a concept stage or a detailed design phase or at the simulation phase, there are quite a few challenges, that we come across. So how do we help the designers with simulations to get the right design in the first place? So what does simulation has to offer in the whole of the design process? So if you look at, if you consider this design phases again, with the use of simulation in the early stages of the design itself and at each of these phases, one can accelerate the innovation, the brainstorming, the innovation decisions that one needs to make, and probably compare the design for different operating conditions. And in the detailed design phase, they can detect the flaws at a very early stage and avoid costly prototypes. And when it comes to the validation phase, we can completely look at eliminating the costly prototypes itself, and then look at zero prototyping. So with the use of simulation, certainly there is a lot of value addition that we can bring in during the entire design process. Now, how do we do this? How do we bring simulation to the designers in the early phase of the design itself? Now, we use this approach, what we call as ModSim, which is nothing but integration of modeling and simulation on the 3D experience platform. So what do we mean by this? So with this approach, using a single platform for both building the model and for performing simulation together on a common platform, the users will be able to get better insights in terms of the design changes they are making. How does that reflect on the simulation that one is performing? They'll be able to make better design decisions in terms of how to optimize the product and choose the best optimal design. So the question would again be, why does one have to select ModSim? Why ModSim? So obviously there are quite a few advantages in terms of what one could look at, mainly in terms of automation, democratization, and integration. So automation, here we are trying to automate the entire simulation process, and we are making it available to the users, and one can perform a repetitive or complex task by using this automated procedure. And when we say democratization, it is just not to the analysts or experts, but the platform is being made accessible to every designer, be it either an expert or a non-expert, in a very simple, elegant, and efficient manner. And integration obviously plays a very important role, wherein in an integrated manner for CAD and simulation, one can really work together and get meaningful insights in terms of the design changes being made and the simulations that are being carried out. And most importantly, the results, the changes can be collaborated within the teams within the organization, or it could also be organizations locally or globally. So today, traditionally, if we look at any simulation procedure, so today we see that the teams are a little disconnected. That is, the design team does all the CAD, and then the CAD then goes for pre-processing, wherein they do geometry cleanup, set the mesh, define loads, boundary conditions, then solve the problem, then finally look at the results. So if you look at all of this process, it could go from days to weeks or even more, depending on the complexity of the problem that one is trying to solve. Whereas if you look at the same process using the ModSim approach, we can drastically reduce the work time from weeks to days, and make use of the associativity that we have on the platform, fully automated process that we have, and one can do not just one domain analysis, but look at multi-physics simulations and optimization. So just to give you an example, if I take, let's say, a product from tool engineering. Now, ideally, let's say if the legacy process would have taken, say, 20 days for us to come up with lot many, design changes, considering various parameters and look at optimization, then doing the CAE analysis for each and every design, and then to come up with the optimal design, probably it's taking somewhere around, say, let's say 20 days. But if I try to replicate the same using the technology and tools available on the platform, we can drastically reduce that time to as less as a day. So if you see here, there is a whole left shifting which is happening on the entire project execution. Now, it could be either in the concept phase or detailed design phase. With the kind of tools that we provide on the platform using this ModSim approach, one can drastically reduce the entire design time or the simulation time. And we'll also see how. So just to highlight some of the key benefits, key values we could bring in through this ModSim approach on the 3D experience platform. So we offer a wide variety of simulation technology in a unified environment. So be it any domain you talk about, that is being offered on a single platform. And keeping the designers in mind, we have come up with applications which would remove the room for guesswork, and which will help designers come up with the best optimal design. And then we could look at seamless integration between CAD, CAE, and the PLM, and it will allow for collaboration, like I said, within the teams internally between CAD, CAE, and managers or reviewers, not just within the organization, but with the global counterparts also, let's say, for example. And the solutions are scalable for all users' skill levels, and the solutions are not being offered. The solutions are also being offered not just on-premise, but also we offer on cloud. So let's take a look at some of these key values in more detail in the next few slides. So, like as I've said, keeping the designer in mind, the applications have built in such a way that there is no room, we allow no room for, say, guesswork, so that the users can come up with the best optimized product design. So once the product requirements are met, the physical behavior can be understood, and a lot of design alternatives can be explored either manually or automatically, and then look at optimization ways to come up with the best lightweight design, and look at increased reliability by doing a lot of durability studies, and then come up with the final design for verification and validation. Now today, all of this is accessible through this ModSim approach, for the designers in the early stages of the design itself, let's say in the concept phase itself. And when we talk about technology, it's just not limited to performing, let's say, just a structural analysis, a linear structural analysis, but the user has the free hand to try out high-end simulations and look at linear, non-linear simulations, or do a thermal analysis or a frequency extraction, durability study. So the entire technology is being offered. And then integration, which is a key. So you could have close integration between CAD and CAE, wherein the changes made in the CAD gets reflected in the CAE model, and it gets updated automatically. And there is full traceability. You get to know who made the changes, why, where, and when. So all of that is traceable. And with this, it allows to perform a lot of design iterations and look at what kind of scenarios for different operating conditions. And then, of course, like as I was saying, collaboration. You could have real-time collaboration with not just the colleagues from CAD or CAE, but it could be with analysts, the managers, and within the local teams, within the organization or globally, all data secured. So there could be full collaboration between different teams across the organization. And scalability, so right from designers to engineers to analysts or specialists. So in terms of scalability, right from designers to engineers to analysts or specialists, we have various tools and technology available on the platform. And when it comes to productivity, you could see all the more benefits. Let's say, for example, we are trying to optimize, a particular design. So we start off with multiple CAD models with, considering various parameters. And then we use the file-based, PLM system to check in, check out files and do the necessary simulations on each of those CAD models that are created. And then finally, again upload and download the results. So if you see, it's all manual and electronic process. And let's say if this took let's say about 16 hours for us to do this level of optimization, using the ModSim approach, we all move to a digital phase, wherein, let's say, with the identified design, we can quickly run optimization studies directly from the platform to come up with the optimal design, and then choose what kind of design parameters are going to be optimal, meeting several simulation constraints, let's say with respect to stress or irrespective of the kind of analysis you're doing. And then you could then share the results with the entire team so that they are aware of the changes made, the design changes that have been considered and all. And probably all of this would take, like, let's say, less than an hour for you to do the similar stuff on the platform using the ModSim approach. Now, as I've mentioned, we have the solution available even on cloud, wherein it's very easy to install and access. Just by following few steps, you could just get it installed on your machine, and then it's instantly deployed, and you can scale it. So probably you could just start with one user, and depending on the usage, you can add in more number of users. It's fully secure. So all of the solutions that we have discussed are available both on premise and on cloud. So I hope you all got a quick glimpse of the key values we have to offer by using this ModSim approach on the 3D Experience platform. Let's get into some action where my colleague Dayanati Panda will take you through a quick demo to showcase some of the values that we have just discussed. Over to you, Panda.
Good afternoon, everyone. I will take through some of those examples. Okay, so I'll show some of those live scenario. So this should be, let me first take through how the platform looks like and what are the functionalities we have. So you could see this is the 3D Experience, the platform, and so this is the compass. Okay. And all the designers as well as simulations guys, so they have to log into 3D Experience platform, and they can access all those jobs. Okay, so in the platform you would see everything is job based. If I would like to do some part design, or I would like to do some assembly design, or I would create some the material definitions, so everything you would see everything in the job based. Okay. So what I have, this is one of the small assembly, and this was created by CATIA users. Okay, on the platform itself, you have created this part, and then as a simulation, or if I'm looking for to do some simulation, I just open that part. So no need to import that part again. Okay, because it's in the same database, so I'm just going and opening that part. And once I open this part, so then I could have, maybe I would like to assign some materials. So in fact, these materials today you are assigning in the design workbench, but again, let's say I would like to assign some new material. So I'll go and search the database. And you'd see there are already material library available. Okay, so any materials I am looking for, I can go and source those materials, and I can apply into my individual part or assembly. So wherever you like, you can apply them. And sometimes, let's say in that material library, you don't have enough material, or you don't have the right material what you are looking to apply. So in that scenario, so what I can do, I can create my own materials and I can save in my database. Okay. So in this one, what I'll do some quick simulations. I'll show you how this process and how it is easy for whether it's I'm a designer or I'm an expert, okay, or is a everyday, or I can be an occasional simulation guy. So I'll go for the simulations workbench. So once I switch over to the simulation workbench, so it will ask me what kind of analysis I would like to do, whether I would like to structure or thermal structural. So let's say I'll do the structural simulations. And then it is asking, do you have the finite element model already exist? If it is already there, so I can go and select. But in this here, I don't have anything. So I have to create one finite element model. Just click the finite element model. Okay, and then I'll say you do it automatic and apply. So now it has created the finite element model. Okay, you see this is the branch it has created the finite element model. And then immediately the right hand side, you would see there is assistant panel. Okay, there is assistant panel, and you see there are some are check marks, the green mark, and some are the red color mark, and some actions, whichever the green marks it shows that action completed, and the rest of it shows some incomplete action. So now you could see there is a new procedures exist. So I have to go and I would like to do some static analysis, some structural analysis. So I will say I would like to do some static analysis. Okay. And then I would like to define some connections. Okay, I would like to define some connections here. So let me go to the model, and then I would like to define some bolt joints here. So there is the bolt that is called the virtual bolt. I can go here, virtual bolt. Okay, and then I can select. So the moment I select one side, the other end, it will automatically pick it off. And here you have the different types of bolt, okay, whether it's a standard bolts or it's a tight fit or it's the countersunk, okay, or you may be tight fit with the head. So there are different options you say available here, and then how you would like to connect them, whether you want to as a maybe I will just make it the rigid, or you could make it a beam. Okay, so then I just apply this, and now because I know these are all 4 bolts are the standard bolts and all are in the same size, and I want to copy this bolt to all these other 3 locations. Okay, so I will go here, and that is called the bolt replications. Go to the bolt replications, select that bolt, find the bolt. So it says there are other 3 bolts. It has identifiers. They are the same size. Okay, and I could go and apply them. Okay. So you see there is. So how much time it takes? So less than a minute. You create your bolt joints and you apply. Similarly here, let's say I would like to apply some pin joint. Okay, so I can go to the connections. Okay, so you see this, there are a lot of options, which are the options available with the connections, which are frequently used. So those options, it will show you in the immediately the bottom side, and you could see that there are small descriptions in each and every icons. Okay, and these are self-explanatory. You can get the basic information there. So let's say I wanted to apply some the pin joint. Okay, so what I'll do, I will select this. In fact, the moment I just selected one side, one cylindrical face, and it will automatically detect the other side also. Okay, and then you apply some how you want to connect them, and then say okay. And you could see this the moment I complete one every individual task, and these things are showing me in the green color check mark. Okay, and now I will go some, maybe I'll create some connections. So I can go to the interactions, and then I have something called surface based contact. Okay, or I could because I want to I want to create those connections, or I don't want to define contact pair individually. So I can go find all the surface pairs, and you could see those all these contact pairs where those contacts are available, or so those things you could see them. If you don't want any of those contacts, okay, so you could ignore, you can remove them, and if you need anything new addition also you can do that. So you can play with these tolerance values. So that way I have defined those contacts. Okay, and now I'll define those boundary conditions. So let me fix some of those maybe these areas, and then I will apply that. Okay, and then next is my load scenario. So again, the same way you would see there are various loads it is available here. And now let's say I will apply some force, and I can select that that area, and then I can say I would like to maybe apply some 50 kg load and maybe compressive load. So this is the load you could apply, and then I will say okay. Okay, so once I have applied my all the once I complete my all the activities, then I have to run my job. So go to the simulate and then run the simulation. And these simulations I am running on the cloud. So there are the multiple way you can solve it, and then how many core you want. If you have more core high-end machines, you want to have quick results, you could do that. Or these kind of problems, whatever the standard the desktop machines we have in those offices, maybe 4 core 8 core, those are sufficient enough to run those analysis. And then it will take maybe a few minutes to complete that analysis. In meantime, maybe we'll see what would be the next problem. Okay, so maybe once this analysis is over, we'll see some of those results, and then I will take you in other problems. Okay, so this is a cradle assembly, okay, for some automotive this cradle assembly. And here you see all those there are maybe more than 10 to 15 parts are there. And I will do the automatic model setup. When I say automatic model setup, I will automatically generate my finite element model. Automatically I will define those weld joints. So I have some laser welds, some spot welds. So those weld joints I will define it here. And then there are some places you see there are some bolts. So all those bolt joints also I will define. And all my materials and thickness, it should read from my geometry. So this would be my next problem definitions. I will show this one also in the live. So now this already the analysis has been completed, and now I could go and see those results. So this is the quickly you can validate whatever the designs you have. So I would say if you do this analysis, I think it will take less than 5 minutes, not more than that. And then you could come out, you can go back to your design, you make some design changes and rerun that simulation. I will show you that step in my another problem, and maybe we'll get more clarity on that. So with this, I'll close. I'll go for the next problem. So this is my the cradle assembly. Okay, and you would see these are the different the parts, and these are the laser weld. Okay, and wherever you see those the points, okay, so you would see there are defined some spot welds, and these are some bolt joints, and we will define the bolt connections. Okay, so what I'll do in this case, we create some rules. Okay, so how you would like to mesh these parts. Okay, what would be your mesh size? Okay, how you want to control your mesh. So we create the mesh rule based on your the requirement, and these rules we save in the database, and whenever we need, we just link those mesh rules into my individual parts or in my assembly. So what I'll do, I'll go to the model assembly design. Okay, so there is called automatic FEM. So I'll go for the automatic FEM, and then I go to the advanced. Okay, and you'd see here there is called mesh and properties. Okay, so I'll go and I will select, this is my rule based what mesh I would like to do, and I will select my meshing rules. So this is already there in the database, already saved someone. I would like to use the same rule, so I'll say this is my mesh rule, and then I would say all my thickness and materials you read from my geometry. So thickness and geometry I'm reading from the thin pad, because these are all these thickness assigned through thin pad features. Okay, and once I have selected my mesh, then I'll go for the connections. Okay, so these connections are pretty much easy, and you could quickly select them. So let's say I'll go for the point detection. So these are mainly for the spot welds. Okay, and I will say select my the meshing the spot weld rules. So again, this is available in the database. So I'll go and select, this is my point fasteners. So I'll select that point fasteners. Okay, and then maybe I will give some tolerance. Okay, and then I will define another connections, and I will my laser welds. Okay, wherever those laser welds are there, or this, or you could say the seam weld or line weld. So I could select them. So similarly, I go here and select the the laser roll here. So this is I would say my the laser rules. So how you will give the connections, and then I could search them, and I will say these are my laser welds. So these are already you created and kept into geometrical set. So I can select that, and then next one I will go for the virtual bolts. So these are the bolt joints. Okay, I would like to create the virtual bolt. So virtual bolt, again, this is the same process. I will go here. So this is my the mesh, the virtual bolt connections details, and this is my the bolt joints. Okay, so I'll go and select a specific rule for that, and then these are some of those the tolerance values. Okay, so based on your geometry data, so you could fit that. So diameter, let's say maybe I will take 15 to the 25, and maybe this is also 15 to 25, and let's say the tolerance is 1 mm, and this is the bolt joints. I'm not sure, but I think this will work for 50 to 100, and these are some of those maximum offset if you would like to give, and then you can give the angle between those axes. And once you have done this, then you can go and just execute, just say apply, and then it will generate the mesh for everything. So now maybe I'll show that. So go to visibilities, and maybe I will hide all these things. Only I will retain my the mesh. Okay, so you could see these are all these mesh it has created, and these are the automatic. It has defined all these bolt joints, and then you'd see those spot welds and the seam welds. So these are the spot welds and seam welds. These are already defined. So you could see more in the details here. Once you have generated the model, okay, then next one is just apply some loads, whatever the load case, and then you apply some boundary conditions and run this model. This entire those assembly again, maybe it will take less than 10 minutes. I would say if you are doing the first time, and also because these are more kind of the BIW parts, so it will do automatic mid-surface extractions. Okay, so no need to be worried for that. So automatic it will do the mid-surface extractions, and it will assign the thickness based on your 3D part. Okay, so this was my second examples. And now I will take you another the interesting examples where I will use both these things, like these automatic model creations, as well as how I have defined those the joint definition in my first problem. All the both the things I will apply in my third scenario or then my next problem, and then you will, I hope you will get more clarity on that. So I will close this one. So before that, maybe I'll give you some maybe the definition of this, what we are doing. So this is I would say this is the cabin, okay, and we'll do some rollover protection structures. I know this is maybe this analysis little bit high-end analysis if we the design engineers they are attending, but I would like to bring out the point. Okay, so you have seen that the first problem, it was a basic problem. Then I have moved to little customized one, like automatic model creation options, and now I'm going little bit I would say high-end simulations. So nothing stops you. So you could do linear analysis, non-linear analysis, explicit simulations, implicit dynamics. Okay, so all those tools are available to you, and based on a requirement, so you could take that advantage. So in this case, so what I will do. So this is the existing cabin. Okay, and then I will apply those rule-based modelings. Okay, so where I will automatic generate my the model. Okay, and then many of those connection definitions also I can capture through automated modeling options. And then I will apply some of those loads, and here I would like to do some implicit dynamics. I will run this problem for a few seconds, this job, and I will see how my results looks like. Okay, so that would be my the first step. Okay, and if you see here, this is something you could apply the force, or in this case I am applying some translation. I am moving this the top part with the some 100 mm downward, and then I would see how my structure will behave. Okay, what would be my structure strength, what is the current the mass of these assemblies, okay, how the energy dissipated from or how the energy dying during those analysis. So those things we will see that. And then next step, what I will do, I will replace my design, this cabin design, with the new one. Okay, so I will replace this the old design with my new concept, and then I will see how both design, how they behave, and which is the better one. Okay, and this is this is not necessarily you will do the implicit analysis. It could be done normal, do structural analysis like static analysis, okay, linear, non-linear. Okay, so those things, those cases also same thing, it is applicable. So what I'm using engineering templates, which is I think many times you must have used this one. So this is a CATIA functionalities. I'm using the same the CATIA engineering template facilities into my analysis domain. So let's say this is the cabin. Okay, so this is the initial analysis is done, and you could see those results. So this is the initial whatever those based on those the 100 millimeter we have applied some translation, right? So you could see how your structure or the structural strength, you could check it here. Okay, whether it's you want to displacement, stress, energies, or reaction forces. So all those outputs, these are already calculated, and it is there already there in the your these results. Again, by default, the software will calculate the default outputs, and if any outputs I need specifically, I would like to monitor those outputs, I can check that. And you would see these are some of those energies parameters, and these are the different plots. Maybe I'll show some energy plots, or the reaction force. So you'll see this is the reaction force. This is the graph for that, and then this is how the force is changing throughout your analysis. Okay, so during an analysis, how your force getting changed. And now what I will do, this is my initial analysis. I have done it, and maybe I now I would try with the this one. Okay, so this is a pure geometry. Okay, this is just your CAD geometry. You don't have any I have not done any I have not created a finite element model. I have not defined any joint definition, nothing, just a simple the 3D part. Okay, so then what I have done, the way you are use the engineering templates. So I am using that engineering template, and I am saying I would like to replace my cabin. Okay, so this cabin I would like to replace. So what I'll do, I will go to my maybe assembly design. So I'll go to the assembly design workbench. Okay, and here I will go for engineering template. So I'll go to the engineering template. So this is my engineering template. Okay, so it is asking me to select which is the engineering rule I would like to use. I would say this is my engineering rule I would like to use, and then it will take a few seconds to take all those attributes into simulation. Let me create one assembly design. Then I'll select engineering template, and then I'll select this is my template, and then it's asking me which part I would like to replace. So I'll go and I will say this is my part, I would like to replace this part. Okay, and then I would say accept it. Okay. So you see this is the your new design, automatic. It has generated your mesh. It has generated your the boundary conditions as per my previous model, and also it has applied the load. So now the next one is you just go and run this analysis, and you can see those results. And then side by side, you can compare both the results. So you go select both the results and then compare those results. So you would see those all those whichever those parameters you would like to, whether it may be mass, it may be your energy, it may be your reaction forces, or the displacement, or those stress. So based on that, all those things, all these outputs, required outputs you will get. Now the Geeta will talk on this, what the next course of us.
Thanks, Kanda, for the nice demo. I hope our users, got a glimpse of how they can So just to wind up this session, some of the key takeaways we have by using this ModSim approach, as you would have seen from the demo and from the discussion we had at the start of this presentation. Certainly, the amount of modeling and simulation time we could drastically cut it down by a large percent, and using a single platform for both modeling and simulation. We can have the designers and the simulation team work in an integrated manner, and also have the designers perform not just basic simulation, but also use the technology that we have to offer on the platform today to be able to do a wide variety of simulations, that is all kinds of multi-physics simulations. And last but not the least, we could use this application on the platform, thereby not having to worry about the infrastructure, the update, the maintenance, and all. As next steps, we would like to hear from you all in terms of, how we could work with you all, and look at one-on-one. We could have one-on-one discussions with you to explore on the problems. Let's say you would like to try out using this ModSim approach. If you would like to get an eval of the platform on cloud, and try it out for your day-to-day problems, so you could always reach out to us or our EDS team, and we could work with you and define a problem that we could demonstrate on the platform using this ModSim approach. So we would be glad to hear from you all. In case if you would like to try this out on your day-to-day problems, we'd be happy to work with you all.
I once again thank you to my colleagues from Dassault Systems for conducting this webinar. And I also thank Mr. Nagananda for all his support. I also thank the audience for taking their time out from their busy schedules and attending this webinar. So that's all from our end. Thank you to the speakers. Thank you to the audience. Thank you.